Assalamu alaikum students, welcome to our channel. Today we are starting a new topic, differentiation worksheet. In this worksheet, we will discuss questions from differentiation and questions from integration as well. So starting with the first question, as you can see on the board, yes, we have a curve passes through the point A 2 comma half, and there is a equation of this. Find the equation of the tangent to the curve at the point A. Now, for the tangent, it's a straight line. We must have a gradient. Remember, whenever you differentiate the equation of the curve and substituting the value of x, you must have the gradient of the tangent. So let's go for it. First thing first, differentiating the equation. So we are going to have dy upon dx, but before this, you must remember for the differentiation, your curve or your equation should be in the numerator. So let's see what is the So let's differentiating the equation. We have dy upon dx. For this, we move this in the numerator first. Y is equals to 8, and I move this bracket in the numerator. What happens? Power becomes negative. Now, let's differentiate the equation, and the method is very simple. What First thing first, the coefficient will remain same when we multiply by the power, which is minus 2. Then bracket will remain same. We subtract 1 from the power. After this, we will differentiate inside the bracket items. First, we will differentiate this x means power 1 here. So we first bring this power down and subtract 1 from the power. The second part of the bracket is 2, which is a constant. Therefore, the derivative of the constant must be 0. Now, we have negative 16 x plus 2 to the power minus 3. Always remember, whenever you solve an algebraic expression, your power should be positive. That's why I better to put this back into the original position, means in the denominator. That's why I move minus 16, and this is x plus 2 to the power plus 3. Now, as I substitute, as I substitute the value of x here, what will happen? Yes, I will get the gradient of the tangent. Yes, you're right. 2 plus 2 to the power 3. It's going to be negative 16 divided by 4 to the power 3, which is 64. Okay. So minus 16 divided by 64, or the gradient of the tangent is going to be negative 1 over 4. This is the gradient of the tangent. Since I'm looking for the equation of the tangent, yes, we must follow the formula y is equal to mx plus c. Let's move further. So we have y is equals to mx plus c. Y is equals to mx plus c. If you look back to the point, yes, the point is 2.5 and the gradient is negative 1 upon 4. So we substitute y as 1 over 2. The gradient is minus 1 upon 4 and the x is 2 with constant c. So it's going to be 1 over 2 and it's going to be minus 1 over 2 plus c. Moving half to the left and it becomes plus half. Therefore, the value of the c will be plus 1. But we are looking for the equation of the tangent. Yes. So y is equals to mx plus c. We substitute m as minus 1 upon 4 and c is 1. Now, the important thing is if you want to stay in this form, that's okay. That's no problem. But if you want to change this format, it's up to you because they did not mention any specific pattern of the equation. So therefore, there is no need to go in detail. This is your required question of the tangent. Okay, boys, let's take the next. Find the equation of the normal to the curve at the point A. Yes. Now, what is the important thing? Remember, tangent and normal always perpendicular to each other, right? I repeat, tangent and normal always perpendicular to each other. And one more important thing, tangent and normal always passes through the same point. That's the key point about the tangent and the normal. So the point A, the coordinate of the point A will remain same, that is 2.5. Yes. But the problem is the gradient of the tangent was minus 1 upon 4 that we have calculated in the part 1. Part normal, yes. Gradient of normal. Since normal and tangent are perpendicular to each other, therefore the gradient will be negative reciprocal. Means you reciprocal the gradient, reciprocal the number, which is 1 upon 4, and change the sign as well. Therefore, the gradient of the normal will be 4. Now, since I'm looking at the equation, the formula is same. Y is equals to mx plus c. Yes. So substitute the values. The y is 1 over 2. The m is 4. The x is 2. Let's calculate the value of c. Yes, we move. It's 1 over 2 equals 8 plus c. Moving 8 to the left becomes negative 8. We calculate and subtract. It's going to be negative 15 over 2. Yes, negative 15 over 2. That's the value of c. But we need equation of normal. Yes. For the equation of the normal, we use again the same formula y is equal to mx plus c, substituting the gradient which is 4 and substituting the value of c which is negative 15 over 2. Again, yes. Since they did not mention any specific pattern of the equation, therefore better to stay in this form y is equal to mx plus c. So let's move further, and the next question is find the equation of the tangent and the normal to the curve at point this. But there's a slight problem. Same question as we did in the previous example, but there is a slight problem. And what is the problem? The problem is we do not have any value of y. Yes, that's the problem. What we do, first calculate the value of y. How? How can I calculate the value of y? Very simple. Just substitute the value of x in the original equation. Yes. As we can see the original equation below, we substitute the value carefully in the original equation and calculate the value of y. Yes. Calculate the value of y. It's going to be 8. It's going to be 2, and that's 9. The y is 1. Therefore, the point where the line is the tangent and normal passes through is x is 2 and y is 1. This is the point where the two lines passes through. But we are looking for the equation, so we must have the gradient. And for the gradient of the tangent, yes, we definitely differentiate the equation. But if you look at the equation, there's a slight problem. Yes. Look at the second term, second part of the equation. Yes. Your x square in the denominator, it should be in the numerator. That's why I bring it in the numerator. And what happens? Sign changes. Yes. Let's differentiate the equation. 2 multiplied by 2x to the power 2 minus 1. Yes. 8 times minus 2 minus 2 minus 1 and 9. Yes, there is no x. It's a constant. Therefore, the derivative must be 0. Okay, first we simplify as much as possible. It's going to be 4x power 1 minus 16x power minus 3. So your dy upon dx is going to be 4x minus 16 over x cubed. Now, if I substitute the value of x in this dy upon dx, what we will have? Yes, which gradient of the tangent. Yes. So we're substituting the value of x, which is 2, in this equation, and we will get the gradient of the tangent, right? Going to be 8, 16 divided by 8 is going to be 8 minus 2. The gradient of the tangent will be 6. That's the gradient of the tangent. Since I'm looking for the gradient of the equation of the normal as well, therefore I calculate the gradient of the normal as well. As you know, the normal and the tangent are perpendicular to each other. Therefore, the gradients must be negative or reciprocal to each other. Means, look at the 6. So if I make it a reciprocal, it becomes 1 over 6. But sign must be changed. Sign must be different from each other. This is the way we calculated the gradients, one of tangent and the other one for the normal. But we need equation. And the equation we must follow y is equal to mx plus c. Yes, y is equal to mx plus c. Y is equals to mx plus c. So first thing first, we will go for the equation of tangent. And we substitute the point, and the point is, what is the point? Yes, that's 2, 1. So we substitute the point 2, 1 here. Y is 1, x is 2, but we need equation of tangent. So we must substitute the gradient of the tangent, which is 6. This is going to be 6. 1 minus 12 equals c. So c is going to be negative 11. Thus, the equation of tangent will be y is equals to 6x minus 11. This is the equation of the tangent. Now, we are looking for the equation of the normal. Formula is same. Y is equals to mx plus c. The coordinates of y are same, which is 1 and 2. Let's substitute the gradient. The gradient of the normal is, yes, minus 1 over 6. It's minus 1 over 6. It's going to be negative 1 over 3 plus c. Moving this negative 1 over 3 to my left becomes plus 1 over 3. They're going to be added, and my c will be 4 upon 3. But yes, the equation of the normal. We put back these values into the equation. The gradient is minus 1 over 6 plus, and the c is 4 upon 3. Yeah. This is the equation of the normal. Again, I tell you, since there is nothing mentioned here, which format should you use for the equation of the straight line? That's why everything will remain in the format of y is equal to mx plus c. Okay, let's move. The next question, let's see what is the next question is. The next question says, differentiate the following. Yes. Okay, what I observe is two brackets. Yes, the two brackets. First, we must expand the two brackets, and then we can differentiate the equation. Yes, how do I expand the brackets? Very simple. The first number is 2x multiplied by the second bracket. Yes. Then the first bracket we have 1 which multiplied by the second bracket again. Okay, let's simplify. It's going to be 6x squared minus 10x plus 3x minus 5. It's going to be y is equal to 6x squared minus 7x minus 5. But we need to differentiate the equation. Okay, so let's start differentiation. So 6 times 2, x to the power 2 minus 1 minus 7 times 1, x to the power 1 minus 1, and yes, the derivative of the constant must be 0. Going to be 12x to the power 1 minus 7x to the power 0. Yes, anything with power 0 becomes 1. Therefore, dy over dx will be 12x minus 7. This is your required answer or the differentiated result of this. I think we should move forward. I hope you have noted down. Let's move. Take the next one. Yes. We have a bracket now. In the case of bracket, very simple. We do not expand the bracket. We just differentiate in the same format. How do I differentiate? Let's see. So dy over dx says first bring down this power and do not change the bracket at all. Then subtract 1 from the power. Draw another bracket. Now differentiate the first part of the bracket, which is 3x. It's going to be 3 times 1 x power 1 minus 1. Now we differentiate the second part of the bracket, which is negative 4. It's a constant, therefore the derivative must be 0. So dy over dx is equals to 3 times 3x minus 4 to the power 2, and this is 3x power 0. So dy over dx, this is 3x minus 4 to the power 2, and this is 3. Why? Because the x with power 0 always becomes 1. Now this 3 will multiply this 3 and makes 9. So dy over dx will be 9 bracket 3x minus 4 power 2. This is your final answer, simplified differentiated result. Now, I hope you have noted down. Moving on to the next part. And the next part is, yes, we have a square root here. Okay, and I hope you have an idea what square root means. The square root means we have a power with which is half. That's a square root. We can write instead of square root power half. Rules are same. Means we cannot open the bracket. We do not open the bracket. First things first, bring down this power and do not change the bracket at all. Then subtract 1 from the power, which is half minus 1. Then differentiate whatever we have inside the bracket. As we differentiate the first term, which is 1, it's a constant, becomes 0. The second term, which is 4x, let's differentiate. The 4 times 1, x power 1 minus 1. It's 1 over 2, 1 minus 4x power minus half, and this is 0 minus 4x power 0. So dy over dx will be, I bring down this negative power in the denominator, that's why power becomes positive, and we have minus 4 in this. Now what happens? This 2 and this minus 4 will be cancelled out. It's going to be dy over dx We have minus 2 here. In the denominator, instead of half, I can write the square root. Therefore, it's better to write the square root in the expression. Otherwise, if you leave in the power half, that's also acceptable. Okay, let's take on the next. Yes, find the coordinates of the stationary point. Stationary point. Key point is stationary point. So whenever they ask you to find the stationary point, your first prime objective is to get the derivative. Differentiate the equation. Yes, that's it. Okay, but before differentiation, we have to make some preparation. And what is, you can see we have a one fraction, single fraction. Let's break down into two fractions in this way. Let's simplify. It's going to be x, and this is going to be 9x power minus 1. Remember, I moved this x in the numerator. That's why it becomes negative 1. Now we be able to differentiate this equation. So let's differentiate the equation. It's going to be 1 x power 1 minus 1. This is 9 times minus 1 x power minus 1 minus 1. Right? So So dy over dx is going to be x power 0 minus 9x power minus 2. As you remember, x power 0 becomes 1 and we move x squared in the denominator. That's why it becomes positive 2. This is your first differentiation. But they ask me a stationary point. Yes. And for the stationary point, what you do, you make dy upon dx 0. Remember, for the differentiation and they ask you about a stationary point, your derivative must be 0. So we put the first derivative as 0. Yes. Now I move this fraction to my right, or sorry, to my left, and it becomes positive. Now I cross multiply, it's going to be x is equal to x square is equal to 9. To remove the square, I'll take the square root on both sides. Therefore, I got 3. But remember, whenever you take the square root, you must have two answers, one positive and one negative. But they mention here the coordinates. Means along with the x, we must know what are the values of y. That's why we substitute each value of x, which is 3 and x minus 3, both in the original equation to get the value of y, right? So let's start with this one. Remember the original equation is x squared plus 9. So we substitute each value of x in the original equation. So my first point is x is 3 and y is 6. That's my first stationary point. Now, I substitute the second value of x into the original equation again. My second stationary point is minus 3, comma, minus 6. This is my second stationary point. But if you read the question carefully again, they mention use the second derivative to determine the nature of these points. Yes, we have to find the nature. Which point is the maximum and which point is the minimum point. And for this, we must use the second derivative. But before the second derivative, what is the first derivative? Yes, we have calculated the first derivative as Yes, this is my first derivative. Before differentiation, yes, before differentiation, I'm going to take a step, and what I do, I bring x square in the numerator. Now I can differentiate this equation. 1, the constant becomes 0. Minus 9 times minus 2 x power minus 2 minus 1. This is called your second derivative d square y over dx square. So my second derivative is going to be d square y over dx square is equals to 18 over x power 3. That's my second derivative. For the nature, I will use the two values of x in the second derivative. Yes. First thing first, we start from the first point, which is 3 comma 4. That's my first point. I substitute this in the second derivative. Remember, we can substitute only the value of x. There is no place to substitute the value of y, right? Remember this. And the second derivative is 18 upon x cubed. So we substitute 18 over x cubed as 3 here. So it's going to be 18 square of 18 divided by 27. What I observe when I solve this, I will get something like 2 over 3. It's not a matter of the number, it's a matter which sign do you have. Look at the second derivative. It gives you a positive answer. So d square y dx square is positive. Therefore, 3, 6 is minimum point. Similarly, we take the next point, which is minus 3 and minus 6, substitute similarly in the second derivative to check the nature of the point. So it's 18 divided by minus 3 power 3. So what you observe, your second derivative is a negative number. Yes. It means second derivative we found as a negative number. Therefore, the point minus 3 minus 6 is maximum point, right? This is the way we find the coordinates of the stationary point. This is the way we find the nature of the stationary point using the second derivative. Okay. Let's move on to the next question. Yes, it says, a point with x coordinates, this and this, moves in such a way that the rate of increase of x has the constant value 0.01 per seconds. Find the rate of increase. Okay. The keywords are the rate. Yes, the rate of increase of x means this tells you they and it's given 0.01. It means they have given the rate of change of x, that is dx upon dt, is given 0.01. It's given. And they ask you to find the rate of increase of y. Means they are looking for rate of change of y. But the problem is the equation they mentioned here has no connection at all with the time. That's why in such case we use chain rule. And chain rule says dy over dt will be equals to dy over dx times dx over dt. If I look deeply in this chain rule, what I see, yes, rate of change of y, this is what we have to find. Dx upon dt, yes, this is I need to, it's given to me, 0.01. The question is, oh, dy upon dx. Okay, it means I have to differentiate the equation first. Then I can use this chain rule. For the differentiation, I can see the equation, there's a square root. It means, yes, the power is half. Rules are very simple. Again, for the bracket. First, multiply by the power. Inside the bracket, nothing changes. Subtract 1 from the power. And now differentiate whatever you have inside the bracket, starting with the 1. Constant becomes 0. Then we differentiate the second part, which is 2x. So it's going to be 2 times 1, 1 minus 1. So dy over dx is going to be 1 over 2, 1 plus 2x to the power minus half. And this is going to be 2x power 0. Now this 2 and this 2 may cancel each other and x power 0 becomes 1. So your dy upon dx is going to be 1 over 1 plus 2x power half. As you notice, I bring down this 1 plus 2x in the denominator. Why? Just to make the power positive. But I have to substitute the value of x4 because I need a numeral answer. That's why I substitute x4 in this first derivative. So 1 over 1 plus 2 times 4 power half. So dy over dx is going to be 1 over 9 power half. So dy over dx means it's going to be 1 over 3. Now, now the time has come to use the chain rule. Yes, time has come to use the chain rule. Let's see how we can use the chain rule. In this chain rule, yes, we have to calculate the dy upon dt. That's the rate of change of y. Dy upon dx, yes, we just calculated here as 1 upon 3. Yes, and rate of change of x, which is 0.01. Right? Now, going to be 1 over 3 and it's 1 over 100. So your dy over dt is going to be 1 over 300 units per second. My question is, can I express my answer in decimals? Why not? You can. But if you write your answer in decimal, it should be in 3 significant figures. That's the key point you must remember. So that gives me, if you don't want to write this answer, you can also write it as that dy over dx is going to be 0.00333. This is your answer. Both answers are acceptable. It's up to you which format you want to express your answer. So that's the thing that we discussed as chain rule in this question number 5. Okay, boys, let's end our class here. Inshallah ta'ala, we will meet again with the next video in which we will discuss more questions regarding the worksheet, regarding the important questions. Till then, take care. Allah Hafiz.